Lesson 13, using radians. Our aim today is let's see how radians can help us calculate sector, areas, and arc lengths. Previously, we have used degrees quite a bit to calculate these values of the area of a circle sector or a length of its arc, and now we're going to try and use radians. All right, so 13.1, what fraction? A circle with radius 24 inches has a sector with central angle pi over 3 radians. Number 1. What fraction of the whole circle is represented by this sector? And 2. Find the area of the sector. So, of course, the first thing I'm going to do is draw the diagram, because even if I think I know how to do it on paper, it's always good just to see things as well. Get a straight edge so I can draw my radius. Okay, so it says the radius is 24 inches and my sector has a central angle of pi over 3 radians. So pi over 3 is really just a third of pi. So the way I'm thinking about this is if I'm thinking I got a diameter, right? That's pi radians, a semicircle. If it's pi over 3, it's about a third of that. Or it's not about, it's exactly a third of a semicircle right here. So that wasn't a perfect drawing of a third of a semicircle, but it's probably pretty close. So they're asking me in number 1, what fraction of the whole circle is represented by the sector? There are actually quite a few different ways you can think about it. So one way you can think about it is how I just talked about. We've taken a third of half of the circle. So 1/3 of 1/2 is really the same as saying 1/3 times 1/2. That word of in mathematics means multiplication. When I do 1/2 times 1/3, I multiply my numerators. 1 times 1 is 1. Multiply my denominators. 2 times 3 is 6. So it would be 1/6 of the whole circle. Another way I could think about it is I know all the way around a circle is 2 pi radians, and I have pi over 3. So this is also going to be equal to pi over 3 out of 2 pi, which is really the same thing as saying pi over 3 times 1 over 2 pi. When I'm multiplying two fractions, if I have something in the top and bottom that is the same, I can cancel it out. So this would reduce to just 1, and this would be 2 times 1 or 2. 1 times 1 is 1. 3 times 2 is 6. A third way I could think about it is I could use degrees if maybe radians is not something I am super comfortable using. I know that half of this circle is 180, right? That's pi radians. That one is one that you should probably commit to memory. This is a third of 180, so that's equal to 60, right? 1/3 of 180 is 60. 1/3 of 18 is 6. So I could think of it as 30 degrees instead. If I thought of it as 30 degrees, that would be 30 degrees. I'm sorry, I just made a huge mistake. It's a third of 180, so that's 60. And I think I said that. I don't know why I wrote 30. It's confusing with the 3's and the 6's. Let me show you what I mean. 180 divided by 3, that is equal to 60. So let me make sure I get that right. So this is 60 degrees out of the whole circle is 360 degrees. And if I divide 60 by 360 on a calculator, whatever tool you use, your mind, well, I'll show you how I do it in my head. Cancel out the ending zeros. That's a little trick you can do. And then 6 divided by 36. Well, I know they're both divisible by 6. If I divide 6 by 6, I get 1. If I divide 36 by 6, I get 6. Of course, you can always just use a calculator to get that fraction as well. But we see no matter how you do it, you're always going to get 1/6 as your fraction. Number 2. Find the area of the sector. So the easiest way to do this would just to be, let me find the area of the whole sector and multiply that by 1/6. So that's what we're going to do. And for this part, it doesn't matter how you got here. It doesn't matter if you thought of it in terms of being being a third of half of the circle, being pi over 3 radians out of 2 pi, or 60 over 360. At this point, you've gotten the same fraction 1 over 6. And we're going to multiply that by the total area. And we all know that total area is really just pi r squared. So this is going to be equal to 1 over 6 times pi times 24 squared. If it's just a non-fraction expression, you can always just write it over 1. So when I multiply these two together, I'm going to get pi times 24 squared, which I do not know. That's 576 over 6 times 1 is 6. Now, when I reduce this fraction, I want to keep it in terms of pi because it's very confusing to talk about something when it's a rational number. It's easier to deal with whole numbers. So we're going to divide 576 by 6. Those are more like terms. So when I divide these, this is going to become a 1. This becomes 96. Because really I'm dividing the top and bottom both by 6. So we get pi times 96, or just 96 pi. And my unit is inches. Since we're talking about area, that would be inches squared for my total area. Really what we did here, if we're thinking about the formula for area of a sector, that formula is, we know it, is theta over 360 times pi r squared. So we're really just showing that there are really a lot of different ways we can calculate this theta over 360. Even if we don't know degrees, we can use our knowledge of radians or just of circles in general to find that out. All right, that's all for 13.1.